So today we will continue with other special products. From today we will enter two particular cases of special products. Some of them are combinations of the special products we have seen. So let's see. Today's topic it's particular case of sum and difference of a binomial. So we remember that sum and difference of a binomial it's something like x plus y multiplied by x minus y. That's the sum and difference of a binomial. So let's see what happens in the particular case. So it says, in this type of exercises, we will combine two special products, binomial squared and the sum and difference of a binomial. Remember, binomial squared, it's x plus y to the second power. And also we have seen that this one is x plus y multiplied by x minus y. So it will be kind of a combination between those. So the rule we need to follow today, it's very similar than the one, or it's the same than the sum and difference of a binomial. It will be the square of the term, but we get to add this s because we can have more than one. So the square of the terms that do not change sign minus the square of the terms, also we can have 1, 2, or 2 that change sign. So that will be the rule for today. So we will have something like the exercise we have on the box. So it will be something like, in this case, x plus y plus c multiplied by x plus y minus c. So in this case, the ones that doesn't change sign, it's x and y. That's we got those that do not change sign squared minus the one that changes sign, c squared. And in the other one, we have another one that it's almost the same, x plus y plus c multiplied by x minus y minus c. So in this case, it's the term that do not change sign, x squared, minus those terms that change sign, y plus c squared. So let's see the demonstration of how we get these specific answers. So in this case, to demonstrate, remember we need to multiply these by the three of them. So it will be x squared plus xy minus xc. Then it will be multiplying the second term by the three of them. So it will be plus xy plus y squared minus yc. And finally, it's going to be multiplying the last one, that it's c. So it will be plus xc plus yc minus c squared. So if we make like term simplification, plus xy plus xy, so we will get something like x squared plus 2xy. Then in the case of xc minus xc plus, we can eliminate it, minus yc and plus yc. So it will be plus y squared minus c squared. So if we see this specific part, x squared plus 2xy plus y squared, it comes from x plus y squared, and this one of course it's c squared. So that's why in this case we can have this specific formula that will apply for this particular case of the sum and difference of a binomial. So let's see some examples. So in the first exercise, you have something like this. We have a trinomial multiplied by another trinomial, but we have the specific particular case that 8x plus 5y doesn't change sign, but 3c and minus 3c, it changes sign. So the rule says it's the terms that do not change sign squared minus the term that changes sign squared. So we can do this one because remember, when we have a binomial squared, it's the first one squared plus 2 times the first one multiplied by the second plus the second one squared. So it will be 64x squared. Then it will be plus 2 times multiplying 8x multiplying 5y. Maybe you can do it by mind. I will do it in steps because of explanation issues. Then it's going to be plus 25y squared minus 9c squared. So it will be 64x squared plus 80xy plus 25y squared minus 9c squared. In this case, it's correctly ordered, so this is going to be our final and correct answer. So it's not complicated. We not only need to follow the rule for sum and difference of a binomial, but applying another special product that we know that it's called binomial squared. So let's see the second example. So the second example is going to be something like this. Two trinomials. So remember, the specific rule says we need to do those that change sign, that do not change sign squared, minus those that change sign squared. So it will be 3x to the fifth squared, that it's the one that doesn't change sign, minus those that change sign. It will be 7x cubed plus 9x squared. So we continue doing it. Remember this one, it's going to be a binomial squared. So it's going to be the first one squared plus 2 times the first one multiplied by the second plus the second one squared. So the answer is going to be 9x to the 10 minus, we keep the parentheses. So first we will have something like 7 times 7, it's 49 x to the 6 plus 2 times 7, I will change this one to a bracket, 7x cubed multiplied by 9x plus 81x squared. So it will be 9x to the 10th minus bracket 49x to the 6th. Then it's going to be 63 times 2, 126 x to the 4th plus 81 x squared. So remember, this minus sign will change the signs of every term inside the bracket. So the final answer will be 9x to the 10 minus 49 x to the 6 minus 126 x to the 4 minus 81 x squared. It's correctly ordered, so that will be our final answer. So if we get something like this with fractions, don't worry, it's the same process. So remember, we need to look for those that do not change sign squared minus those that change sign squared. So it's going to be something like this. 2/3 of a to the 5th plus 3/4 or 3/4 of b to the 4th, all of it squared, minus the one that changes sign, in this case 4/5 c to the 3rd squared. So in this case, remember this one, it's like doing a plus b squared. So it's going to be a squared plus 2ab plus b squared. So it's going to be a squared, that it's 4 over 9 a to the 10. Then it's going to be plus 2 times multiplying 2/3 of a to the 5th, multiplying 3/4 of b to the 4th, plus 9 over 16 b to the 8th, minus 16 over 25 c to the 6th. So the final and correct answer is going to be 4 over 9 a to the 10th. Then here we can simplify 3 and 3, so it will be 2 times 2, it's 4. So we can simplify it, so it will be only plus a to the 5th b to the 4th plus 9 over 16 b to the 8th, and finally minus 16 over 25 c to the 6th. And this is going to be our final and correct answer. So let's see other example. So let's see this particular case when we have letters as exponents. Don't worry, it's the same. In this case, remember, it's those that do not change sign squared. But in this case, check the one that doesn't change sign. It has one positive and one negative. So we need to left it like that. So it will be 5x to the 2v minus 3x to the b plus 2, all of it squared. So need to see like we respect the signs of those that do not change sign, minus the one that changes sign squared. So remember this one, it's a minus v squared. So it will be a squared minus 2av plus b squared. So our final answer is going to be 25x to the 4b minus 2 that multiplies 5x to the 2b multiplied by 3x to the b plus 2 plus 9x to the 2b plus 4 minus x to the 6 minus 2b. So we need to multiply the one that it's on the center, so it's going to be minus 30x. It's going to be 2b plus b plus 2 plus 9x to the 2b plus 4 minus x to the 6 minus 2b. So the final answer is going to be 25x to the 4b minus 30x to the 3b plus 2 plus 9x to the 2b plus 4 minus x to the 6 minus 2b. And this is going to be our final and ordered answer. So you can see it's the same. We can do it with fractions. We can do it with letters as exponents. It's the same. It's following the specific rule of a difference of a binomial and use also the rule of binomial squared. So let's see one last example. So let's see. In this specific example, we have one that do not change sign, that it's 7x, but the ones that change sign, in here we had negative and positive, here we have positive and negative, so we need to respect that they have different sign on each parenthesis. So in this case we need to put like the one that do not change sign squared minus those that change sign squared. In this case, we need to put one positive and one negative, because we saw like in this parenthesis we have one positive, one negative. In this one we have one positive, one negative. They don't have the same sign in each parenthesis. So here we will need to put one positive, one negative. You can put any one of them positive and the other negative. Because of order, it's normally used the first one positive, the second one negative, squared. So it's going to be the final answer. Of course, this part, it's the one that it's a minus b squared. So it's going to be a squared minus 2ab plus b squared. So the final answer is going to be 49x squared minus, I will put a bracket, it will be 64y squared. It will be minus 2 that multiplies 8y that multiplies 3c plus, it will be 3c squared. So it's going to be 9c squared. So it's going to be 49x squared minus bracket 64y squared. Then it's going to be minus 48yc plus 9c squared. So our final answer is going to be 49x squared minus 64y squared. Remember, this minus sign will change all the sign in the parentheses, so it will be plus 48yc minus 9c squared. So this is going to be our final and ordered answer. So only remember this specific like trick. If those that change signs, we have one positive and one negative, one positive, one negative, we need to respect that here we need to put one positive and one negative. So that can be a little tricky sometimes. So be aware of this specific exercise. But it's always to do a combination of sum and difference of a binomial and of course binomial squared. So it's only applying that combination in even possibilities that we can have. So now you are done for today. We can do activity that it's called particular case of sum and difference of a binomial. So we will see on the next topic.